Today we are going to start learning about box and whisker plots. The first thing that we're going to do is we are going to learn how to read them and answer questions about them. Okay, so on page 4, you will see a box and whisker plot, or sometimes they call it box and whisker graph. Now let's talk about some things that you need to know about a box and whisker plot. The box and whisker plot is made up of a 5-number summary. Okay, that's minimum, maximum, quartile 1, quartile 2, and quartile 3. It's called a 5-number summary because these are going to be 5 numbers. Now, sometimes the minimum is also known as the lower extreme. And so the maximum would be known as the upper extreme. Okay, then you have quartile 1, 2, and 3, which are all medians. Quartile 2 is the median of the entire data set. Quartile 1 is the median of the lower half. And so quartile 3 would be the median of the upper half. Once I write this, we'll have to erase it because it's kind of running into everything. Yeah, but later. Okay, so the box and whisker plot or graph is made up of the 5-number summary, which is the minimum, also known as the lower extreme, the maximum, also known as the upper extreme, and then quartile 1, 2, and 3. Quartile 2 is the median of all the data, so the middle of all the data once it's in order from least to greatest. Quartile 1 is the median of the lower half, and quartile 3 is the median of the upper half. Okay, go ahead and write that down because I'm going to have to erase it. What? We're about to learn it. Okay, can I erase that now?
No, she can't. No, you can't.
Can y'all just be quiet? Alright, now, on the box and whisker plot, this is what stuff is. This whisker is the lower extreme, or the minimum. This whisker on the right side is the upper extreme, or the maximum. And then the box is made up of the 3 quartiles. The first line of the box, so the far left line of the box, is quartile 1. The second line of the box is quartile 2. And the third line of the box is quartile 3. Now obviously, you're using a box and whisker plot to represent a data set. So like this could represent your test grades from the last test. So 100% of the data, everybody's score, would be represented in this box and whisker plot. So obviously 100% has to be broken up. From the lower extreme till quartile 1 is 25% of the data. So as you can see, not a lot of people in the class scored between a 38 and a 72. 25% scored between a 72 and an 88. 25% scored between an 88 and a 96. And then the top 25% of the class scored between a 96 and a 102. Have you ever received scores back from like a PSAT or something and it'll tell you you were in the top 25th percentile or whatever? That's how they're getting this information. Okay, they're taking everybody's data and they're either doing a box and whisker plot or something. Okay, and that's how they find that out, where you fall in the data. Okay, so now that we've talked about these things, let's try to answer some questions about the box and whisker plot. What was the high score on the test? A 102, because that's what the upper extreme goes to. This is a U, even though it kind of looks like a V. Upper extreme. What percent of the class scored above a 72? 75%. Because if you go to 72 on the box and whisker plot, it's at quartile 1. And look, 25 plus 25 plus 25 is higher than that, so 75%. What was the median score on the test? 88. Remember a while ago when you were writing down those notes, I said that Q2 is also known as the median of all the data, so that would be an 88. What percent of the class scored between an 88 and a 96? 25%. Do you think the test was too hard for the students? Why not? Correct. 75% passed the test. I mean, yeah, that's how I kind of decide whether to make a retake or not. I kind of just go by if the average of the whole class was 70 or higher, we don't do a retake. Okay. Would you expect the mean, so the average of the data, to be above or below the median? Well, where is the median of this data? Remind me again. It's at an 88. So would we expect our average of all the data to be higher than an 88 or lower than an 88? What do you think? Just trying to guess using some common sense. A little lower. And let's talk about why. See how most of the data is to the right side? Okay, the majority of the data is to the right side. Well, there's something you learned in 9th grade called skewed. Okay, data can be skewed left, skewed right, or symmetric, which that should have 2 M's. Okay, our data looks like this one. Even though our data is not this type of graph, it's a box and whisker plot. See how most of the data in this one is to the right side? That's known as left skewed. Okay, if most of the data leans to the right, it's known as left skewed, and the mean will be below the median in that case. If the data leans to the left, which is called right skewed, the mean will be above. And then if it's symmetric and the data looks to be like pretty much in the middle, the mean will equal the median. Okay, so just look at those for a second. Remember, if the data is symmetric, meaning like our box was right in the middle, that is symmetric distribution, and the mean and the median would be equal. If the data is right skewed, most of the data is on the left side, which is not the one we're looking at right now. Turn around and pay attention. And if the data is left skewed, more of it is to the right, and that would place the mean below. Now, the reason it's below is because this outlier is way over here at 38, so it pulls down the mean. Okay? We pretty much know that 50% is above an 88 and 50% of the data is below an 88. So when you're considering 0 to 100 for a test, or in this case 102, if 50% of the data is below 88, isn't the mean going to be below an 88? So you would write it like this. The mean would be below the median. And you can just write, if you're running out of room right there, you can put median at 88. Because the data is skewed left. Okay, so anytime your data is skewed left, your mean is going to be below the median. If it's skewed right, the mean will be above the median. Yeah? Yeah? The mean would be below the median because the data is skewed left. Either way. Okay, now before I just do them with you, I want you to take a couple of minutes and look at this box and whisker plot and answer questions 7, 8, and then on the next page 9, 10, and 11. Go ahead and try 7, 8, 9, 10, and 11 looking at this box and whisker graph. Number 7. What percent of sophomores watch TV for at least 15 minutes per night? Am I on the wrong question? Sorry, that was the next page. What percent of sophomores spend more than 60 minutes on homework per night? 25%. Okay, because we're looking for more than 60 minutes. So that would be from here and higher, and that's 25% of the data, right, Grant? Number 8, what is the range of times that the middle 50% of sophomores spend on homework per night? What? 40 is correct. Let's talk about how you get that number. The middle 50% would be from 20 to 60, right? Because that's the middle 50. This is the lower 25, this is the upper 25, so that would be the middle 50. And the middle 50 ranges from 20 to 60, which is a range of 40. Okay, next page. I mean, that's fine, but you would have to know if it's multiple choice and you didn't see that to go ahead and subtract them. How many sophomores do not do homework? Okay, well, let's look. Didn't you have at least one sophomore that when surveyed said they did 0 minutes? So at least one kid said 0 minutes, right? But we don't know that it's only one, because you'll see today when we start creating box and whisker plots, this whisker can represent more than one data item. So for this, you would just need to put at least one. Or you could write that like this, greater than or equal to 1. What percent of the sophomores spend less than 20 minutes per night on homework? Okay, less than 20 minutes would be from here back, which is 25% of the data. Can you please be quiet? What? Would you expect the mean number of minutes per night to be higher or lower than the median? Higher, and why? How is the data skewed this time? Correct. More of the data is shifted to the left, which is called skewed right. So higher because the data is skewed right. Okay, now what I want you to do is I want you to try the next one by yourself, TV and homework minutes per night. And you're going to work on 12, 13, and 14. So just the bottom of page 5. Try that by yourself. For questions 12 through 23, which right now you just did 12 through 14, refer to the box and whisker graphs below that compare homework time per night with TV time per night for the same group of sophomores. Okay, so here's the box and whisker plot that has the data for them for homework time. You can see that homework time for these sophomores ranged from 0 minutes all the way up to 190 minutes. Okay, that's a little unrealistic, but whatever. And then their TV time ranged from 0 minutes all the way to 225 minutes. What percent of sophomores watch TV, so focus on this one, for at least 15 minutes per night? 75%. Because at least 15. Wouldn't that be 15 or more? And look, 25%, 25%, 25%. 15 or more is everything from here over, so that's 75%. What is the third quartile for TV time data? What is the third quartile for TV time data? 110. Look, remember the third line in the box is quartile 3 and it's at 110. Is it more common for a sophomore at this high school to spend more than an hour on homework or more than an hour watching TV? Watching TV, because all you had to do is look at more than an hour on homework. What percent spent more than an hour on homework? 25% spent more than an hour on homework, because all you would do is go to the homework box and whiskers plot. There's 60, which is 60 minutes or an hour, and from there to there it's only 25% of the data. Then for watching TV, here's 60 minutes. So from here over is 50% of the data. So twice as many watch TV for more than an hour than did homework for an hour. Okay, now I'm going to leave this part projected on the board so that you don't have to flip back and forth. but I want you to turn to the next page and answer questions 15 through 23. They're true, false, or cannot be determined. Number 15. Some sophomores did not watch TV that night. That is true. Because if you look at the box and whisker plot, you'll see that at least one kid said that they watched 0 minutes. So some sophomores didn't watch TV is true. The TV box and whisker graph contains more data than the homework graph. This is actually a little bit tricky. It's false because it doesn't mean any more data is there just because they watched more TV. The same group of sophomores was surveyed. So don't you think if they surveyed 100 kids about homework time, they asked those same 100 kids about their TV time? So the same amount of data is there. Okay, it's just the range of the data was a little bit different. So this is false. Number 17, 25% of the sophomores spend between 48 and 60 minutes per night on homework. Okay, homework between 48 and 60 would be 25% of the data, so that's true. 15% of the sophomores did not watch TV that month. Okay, so cannot be determined. Okay, we cannot figure out what 15% did from looking at a box and whisker plot. If you had every single student's data, you could. But with just the box and whisker plot that was constructed from the data, you can't. In general, these sophomores spend more time watching TV than doing homework. True. Okay, that one's kind of a no-brainer. When you look at the box and whisker plots, you'll see that they spend a lot more time watching TV than they do homework. The TV data is more varied than the homework data. This is actually true, but we haven't talked about it yet, so you might not have known. Varied means more spread. See how the TV time, the data is more spread out, the box is much bigger? That's more varied. Okay, so anytime it asks you about more varied, they're asking about the spread of the data. And if the box is bigger, it's more varied. The ratio of sophomores who spend more than 110 minutes per night watching TV to those who spend less is about 2 to 1. That's false. Let's talk about why. What percent of sophomores spend more than 110 minutes per night watching TV? 25%. So what percent spend less than 110? 75. Well, 25% to 75% is not a 2 to 1 ratio. It's a 1 to 3 ratio. 225 sophomores watch TV. This is a cannot be determined. This is kind of a trick question because they throw out that 225 and they automatically expect you to look at 225. But this 225 represents what? Minutes. And they're talking about sophomores. Well, do we even know how many sophomores were surveyed? So cannot be determined. Twice as many sophomores watch TV for more than 1 hour than do homework for more than 1 hour. It's true. Okay? Okay, let's look at watch TV for more than an hour first. TV time, 60 minutes is an hour, so 50% watch it for more than an hour, right? Okay, so 50%, 50% watch TV for more than an hour. Let's now look at what percent do homework for more than an hour. Homework for an hour is only 25% of it. So that is twice as many, so it's true. Okay, now we're going to talk about how to actually construct a box and whiskers plot when you're given a list of data. First, let's talk about what this data is. Suppose that one family kept track of how many DVDs they rented each month for a 2-year period. Okay, it's a 2-year period, so look. January, February, March, April, May, June, July, August, September, October, November, December. That's year 1. And then here it goes again, year 2. They recorded how many DVDs they rented each month. Okay, so that's where the list of data comes from. We're going to make a box and whisker graph from this data. Well, the first thing you have to do anytime you're asked to create a box and whisker graph or plot, you have to put the data in order from least to greatest. Okay, so that's probably going to be the most time-consuming thing, is putting it in order from least to greatest. What's the lowest number? And how many are there? Okay, and I would cross them out as you've used them. That way you know you've used them. Okay, what's the next lowest number? And how many are there? Correct. What's the next lowest number? And how many are there? Okay, next lowest. How many are there? 1, 2, 3, 4. Okay, the next lowest number. How many are there? 2. Okay, next lowest. Okay, no, there's 1, 2. There was one in February the first year. June. That's June. It's after May. May, June. I know, but the 5 was under the first J. July, they didn't watch anything. They were watching fireworks. Okay, the next one. How many of them? Okay. 1, 7. Okay. No, 2 8s. April of the first year, July of the second year. Okay, then 9, November, and then October. And then 110, 111. Okay. Now that the data is in order, you're going to create what we call a 5-number summary, which we already talked about at the beginning of class. The 5-number summary is made up of the minimum, otherwise known as the lower extreme, the maximum, otherwise known as the upper extreme, and then the 3 quartiles. Quartile 1, quartile 2, quartile 3. You can, yes. But since we haven't listed all this data in our calculator and we don't have time, let's just do it by hand today. What's the minimum? And see how there were 2 zeros? Remember a while ago on that question when we put at least 1? Because I said a whisker doesn't imply that there's only 1 data item there. It can be more than 1. Okay, we have 2 numbers that'll be at that low whisker. What's your maximum? But on that side, only 1 data item will represent that whisker. Okay, the first one you have to find is the median of all the data, which is your Q2. How do you find the median of all the data? The middle. The median of all the data, right, it's already in order, so we just look for the middle, right? But with a 2-year period, how many months is that? So is there going to be an exact middle? No, so we need to count over 12 from each way, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So December, and then if you go this way, it'll be January. What is the median? Because they split the middle. So what do you do to find the median? Right, 4.5. The middle of 4 and 5 is 4.5. Turn around. Then to find the Q1. Q1 is the median of the lower half. The lower half is now from January to December. So the first year is the lower half. Okay, what's the middle number of that data? Is there an exact middle? No, because there's 12 numbers. So wouldn't the 6 number over each way split it? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So what is the middle of 2 and 3? 2.5. Because there's 2 of them, so you just have to find the middle of those. Okay, the upper half, or Q3, is the median of the upper half, which would go from 5 over to 15. From January to December. And in that data, the 2 8s split the middle, so it's 8. What? Oh no, we just didn't have time to type them in today. Okay, tomorrow we'll talk about how to put these numbers on the box and whisker graph. You may switch out.